In this video, I'd like to talk about something called graphs. Now, graphs are another type of nonlinear data structure. If you remember, our trees were nonlinear. They might look something like this, right? Meaning that they're not in this continuous linear fashion, unlike something like a built-in array or even a linked list, right? Which is also linear like this, right? Now, graphs sort of take this idea of trees or linked lists, the way that this data is structured, and gets even a little more complex with it. Say we want to represent something like the airports around the United States. So here's my map of the US. This is a absolutely terrible map, but go with it for me. We have a map of the United States, which looks something like this. And on this map, we have a series of airports. We have Boston, Orlando, we got Chicago, somewhere around here, Seattle, we have somewhere down here in Texas, and maybe Los Angeles. And as an airline company, we need to keep track of which airports can have or have flights to other airports. And visually, we may draw it something like this, where maybe Seattle has a direct flight to Boston, and Boston has direct flights to Chicago as well as to Orlando, and maybe it also has direct flights to LA. Seattle may also connect to Texas, Texas back to LA and to Chicago. Orlando maybe also has flights to Chicago, and let's say it also has flights to somewhere in Texas, right? This data structure that I just drew here, this is a graph data structure. To clean this up a tiny bit, our graph data structures are comprised of two things: nodes and connections. Here's another example. A connects to B, connects to C, D. Here's a very simple graph, which is made up of 4 different nodes, A, B, C, and D. And it has 4 different connections part of it. It's got this one here, another one here, another one here, and another one here, right? This type of graph is sort of the most simple and straightforward one, with 4 nodes and 4 connections. And graph data structures like this, where any node can connect to any other node, is really commonly used for a whole bunch of different types of data that may not fit inside of a better data structure, or inside of a data structure that you've even explored before. This sort of data structure is very commonly described as something that could be used for airports and connections between them. It could also be used for something like social networks, right? If I'm here, Dave, and I'm friends with Billy and Claire is friends with Al, and Billy is also friends with Al, that could be represented by a graph data structure like this. And now, using this data structure, we can even do a little bit of logic on it, where we could say, well, how would Dave get introduced to Al? Well, I could talk to either Billy or I could talk to Claire, right? And we could see that that's the case if we sort of look at these pathways that are created from David through Billy to Al, and then from David through Claire to Al, right? So we can do some interesting logic based on these sort of graph data structures. These things are used all over the place in game development as well. Almost every single modern video game in some way uses a graph data structure. They are very commonly used in keeping track of the various levels in like an overworld. If you were playing something like Super Mario World, and you're in that overworld where you are sort of hopping between these different nodes, and I want to go to level A or level B, and I'm following these path connections between them, that's a graph data structure. If you were to create some sort of pathfinding system in a larger 3D game, these nodes might represent the different rooms inside your game. You may have walls and hallways that kind of connect how your rooms are laid out, something along these lines. And Maybe these spaces are how an AI character can go from over here, position D, follow along to position C, and then move to position A, right? Our patrol points that we have inside of any sort of video game may be represented by a series of nodes and connections like this, where they kind of double back on themselves, right? Or follow these other sorts of positions and move throughout the world, right? Where each of these nodes are representing 3D positions. When you go on LinkedIn and it says that you are 2 connections away from another person, right? It's using a graph data structure based on your friends and your relationships and determining how you get to someone else, right? When you're on Facebook and it says that you have 2 mutual friends, right? This is that relationship here. Dave has 2 mutual friends with Al, right? So this is the exact same underlying data structure as these social networks are using, as airplanes would be using to track their flights, as we would use inside of for some artificial intelligence for doing pathfinding and path planning in video games. In a nutshell, graphs are comprised of nodes and connections. These nodes can represent any kind of data that we want, just like with trees or linked lists or vectors. These nodes can represent 3D positions in our game, or people, or strings, or integers. These connections sort of maintain how these are related to each other, right? So A has some sort of logical connection to B, and B has some sort of logical connection to C in some way, whatever that might be. This could be a skill tree that you're playing on through a game. So I unlock this skill, and then because of that, I can unlock these adjacent skills next, and then sort of traverse my way out through this skill tree. There's a whole bunch of possibilities about what this data structure graphs could represent.